Um, so today I wanted to just spend a bit of time um, going through just the real basics of um, interacting with fire servers. If you are sort of familiar with the fire APIs, this will probably not be news to you. But also I'm just going to point at a few of how some of this interaction needs to also be defined in terms of implementation guide work, and sort of defining required capabilities for systems and how that supports particular use cases. So as part of the sort of HL7 Australia standards work, with AU Core and Provider Directory and other sort of usable implementation guides, we need to be able to say how do we interact, as well as defining the data structure of things. We need to be able to define how to interact with servers. So I'll just run through this stuff. I'm hoping this won't be too long and we'll have time for questions and such. So I'm going to jump straight into it. So in the fire specification, we have a set of interactions that are possible with fire servers. This is lifted straight from the fire specification, and gives a sort of different levels of interaction. If people are sort of familiar with resource-based RESTful interfaces, this is essentially following that kind of pattern. So some of this will be familiar. Fire has a specific way of sort of approaching managing resources as data through a RESTful API. It's applied across all the resource types. So basically all the resource types work the same sort of way, and they all have their own sort of set of search capability and things that's defined as part of the standard as well, which we'll have a look at. I'm going to concentrate. So it's split here into instance type and whole. This is, I think it's probably good to show just the an example of what that kinds of means. When we're talking about interacting with fire server, we're talking about HTTP based protocol interfacing with the system. So we're talking about using regular HTTP verbs like.
By the way, Brett, are you
Yeah.
supposed to be sharing your screen?
Oh, I am. Thank you, Marvin. I have not shared my screen, which is an important fact. Thanks for that, Marvin. I would have discovered that much later. Cool. Okay. Does that look like a slide?
Yep, looks good.
Thanks, Marvin. Yeah, so we have these different levels of sort of interaction. So we have, that's probably best done by example. When we want to say, I'm just going to cover some of the interactions here, which are sort of the core main ones that we'll mostly be talking about, I think, in working groups, to sort of define the basics of what we need. But there is more to it, especially if you have full working fire servers available to you. These are all relevant for doing different sort of interactions that are important. So, a primary concept might be to create a resource. So patient is a favorite reference resource type. So if you wanted to say create a patient on a system, each fire server is going to have a base URL. So that's essentially where your fire server is located. So it'll have your domain and whatever other path to the base path of the fire server. And then the standard way to sort of create a patient is to post a patient resource to that endpoint. So if we post it to the patient, we need to include content. So we'll talk a little bit about just defining the content. We sort of, I think people have sort of seen us talking about resources and the structure of resources and the elements, and that was part of the previous sort of this session on the intro stuff. So basically we're talking about creating an instance of those things, you know, on a file server. So it uses a post to do that. Once that is accepted by the file server and that patient record is now stored, it gets allocated an ID. So that ID is one that the server's provided in a response on that post. We now have the ability to reference that patient that's created, so we can actually get the content back again using a get call. So this is reading a single instance. So we're talking about we've used create a patient resource as a type of resource, and then we've said we've also can now read that back as a patient resource. So we've just referred to that ID directly in the get call, and we're able to pull back the details on that. So if we want to do searching, so another common thing we want to do is actually find records based on some criteria. So we might want to there's you know, a set of those which we'll have a look at some of the sort of things that are possible with that. But you know, here's a simple one, which is doing a search with by family name. So this, you know, it will return a set of matching patients that match that family name search. There's actually also a post version of a search as well, which it does the same thing, but lets you. It's much more friendly for doing posts from say forms directly. So you can directly do file searches directly from a web form or something like that. It gets a possibility as well. So we just have these extra parameters on to define the search criteria. If we have an existing record, it's possible to update the content. So by using a put verb, we can supply an updated version of the patient resource, and that lets us essentially update the content that exists already in the system. It's also possible to use put to create a new record if it doesn't exist. So that's actually a nice way to create a record where you depending on your server, the file server in action, it might be possible that the file server will allow you to allocate your own IDs. So in this case, we can essentially say we want to use ID. If it's an existing ID, it'll do an update to it. If it doesn't exist, it can create a new one with the ID that you've supplied. So that's quite handy if you want to keep the IDs the same in one system to another system and copy it across into a file server. It's also possible to do deletes. The actual internal management of deletes in file servers is up to how that server is implemented. There is a set, essentially, file servers generally have auditability and some ability to see deletions and be able to see those things. So people, I think, in health are very aware that deleting sometimes doesn't mean entirely deleting, it just means not making it available anymore. It depends on your file server how that's actually handled, but that's a way to make a resource that's not going to be searchable anymore and won't be available if you try and get it back with a read. There's also the idea of sort of whole, it's marked as whole system interactions, but this is where we may be submitting a set or a group of resources. So the two big approaches to that are a batch of things to do. So that might be something like I have a batch of patient resources. That's essentially some patient list that I have, and I want to be able to add them into my file server. So I can create a batch of these patient resources and post them in together. And that'll be executed one by one, and there'll be a response saying how successful we were for each of the posts of those records in. It's also possible to do transactions with a system. So transactions are really important where we have a set of resources that need to go together. So an example might be we have a record that contains a patient, the managing organization for the patient, their usual GP that gets referenced from patient, and maybe a couple of observations that reference that patient. And we want to make sure they all get submitted together in a record. So there is a possibility of doing a transaction post, which puts all of those resources together to get created in the system. If there's a failure, there's essentially a rollback, like any sort of transactional system, which means they either are all successful or the actual whole submission is rejected with errors coming back. So that's kind of gives you a flavor of what the sort of interactions we're talking about are. So one other thing I wanted to point out was this idea of a capabilities statement. Now, this is something where an interface or a set of capabilities can be described using a FHIR resource. So the basic sort of FHIR server capabilities statement for a FHIR server is achieved by accessing this metadata endpoint here. That will give you a response that shows you the capabilities of what the FHIR server can do. So whilst if you're buying an off-the-shelf full-blown FHIR server, it probably has the capability of doing all the resource types and all the interactions that are possible. If you're implementing, say, a facade over a system, you might be able to only do read activity and not allow write back, or you might have only a certain set of resources that you support. So initially I expect, like a lot of systems that are existing systems, building interfaces will have a capability statement that said something like, oh, I support patient and practitioner, and then as you build up the capability of your system, you can describe more things that you can do, and that will include things like can I do searching, can I do read and write, and actually lets you describe that in some detail, which is super helpful if you're another system trying to connect to it. As a consuming system, I probably have a set of requirements of things that I need to exist or interactions that I need to have available to me. So by having that capability of being able to read that back from a FHIR server, I can immediately know if I can achieve a connection successfully with it that's going to be able to achieve the business that I want to achieve. So that's kind of, there's a whole bunch of other things there. So there's certainly, I might just run through those sort of quickly. There's this vRead concept, which is, I won't get into detail, but vRead is like showing an audit trail of changes for a particular resource. Actually, sorry, that's reading a particular version of a resource. So if you have a whole series of changes to a resource, it's possible to select a particular version of that as something that you reference. So that's helpful if you want to essentially maintain like a snapshot of something that's at a particular point in time, and also lets you go back and look at the history, in some ways as well, as depending on which version you were looking at to do your business. There is support for patch as well, which is essentially being able to update specific elements inside, read and update elements. That lets you update specific elements in a resource. So it means you don't have to supply the whole resource to update some of the content. That's a more sophisticated sort of update mechanism that usually full-blown FHIR servers will have available. There's a history call, which lets you look at the instance level. The history call lets you look at the entire history of a particular resource, so from its creation, all the changes, and up to the current version. So that's helpful if you want to do auditing and understand the changes to a particular resource over time. There's a history level interaction at the type level, which shows you essentially all the changes done on that particular resource type. So that will show essentially all the changes made on any patients in the system. So you can say, oh, you can see like through the life of the system, you probably say, look back through the history and go, oh, the last thing that happened was this patient was created, and I can see there was an update on a different patient, and this other patient was deleted. So it's a useful way to sort of have a picture of all the changes going on a particular resource type. There's the same sort of history concept across the whole system. So rather than just saying changes to patients, you can say changes to any resource, which effectively is a like describing almost like a change feed sort of concept, where you've got all the changes happening on a Fire server available to you. And there is a search across the whole system, which is a slightly scary concept of being able to search by a particular type, regardless of a particular type of criteria, regardless of the resource type, which I haven't seen used a lot, but it's something you can do. So basically interacting. So actually, at this point, I might just break out. Actually, I might do this slide and then break out and show what I'm talking about actually with the system. When we're interacting with the Fire server, there's a couple of key HTTP headers that go along with the interaction. So on your as part of the interacting with the HTTP interface of a Fire server, there's an accept header. So the accept header is a standard HTTP header which describes what kind of response I would like to receive from the server. So in the case of a Fire server, you might be interacting with it in a browser. So some kind of HTML-based response might be a nice thing to get. So that would be something that gives you, sort of a nice readable version of a response. But if you're an actual client system, you probably want to get it in actual data formats in responses. So these MIME types down here, for XML and JSON Fire representations have been these have been registered with IANA. So these are actually known MIME types, which basically describe the XML and JSON version formats of Fire. So these are so you can actually request that you'd like the server to respond as JSON or respond as XML. Now, the server might not be able to do some of these things depending on what your implementation is. It's certainly something, though, that a full-blown Fire server, this is definitely something that you have the option of choosing how your response comes back. And you might think it's a bit weird that you're asking for response formats on things like a delete, where there's going to be usually no actual response provided. So Fire does have this operation outcome resource, which is essentially a resource that can come back on interactions that lets you know information or errors that have occurred on the interaction. So it is possible still to get a Fire-shaped response out of a system, even though normally, if you're trying to do a delete and it failed, you probably wouldn't expect a response. But it's certainly possible, and Fire servers do this. If there's something that the Fire server can say that's useful, you can actually get an operation outcome coming back to say an error has happened. So along the same lines, when we're actually posting or putting data up to a server, we have to specify the content that we're supplying. So in this case, we'll say, well, we're posting an XML version of something or a JSON version or something in Fire format. So we have to sort of identify what we're posting in that case, and this is the specific MIME types to use for Fire. So when we're sort of interacting with it with services, typically we can do sort of resource level interactions, so patient, practitioner, and sort of the single resource concepts there. And if you just have a single resource, say I can get a single resource, I can post a single resource, put a single resource, and delete a resource. That's kind of operating at a resource level. But it is also possible to post and get results back as sets of things. So if I say do a search on the system, I'm going to get a set of results. And the way that's supplied back in Fire is using the bundle resource. So a bundle is really just a whole set of resources coming back to you in a group. And it's a way to sort of package those up into another resource that lets you receive a whole set of things back as a response. And also bundle is needed if you want to create a group of things to submit. So if, say, we're submitting a batch of things, they have to be sort of housed inside this bundle as a set of resources to be able to push them up to a Fire server. So it gives you essentially an object that that you can place a whole bunch of resources inside and be able to post that up on your actual interaction. So at this point, I will probably just, now, if you're sort of familiar with Fire, this will be not too exciting, but if you're kind of new to it, this is probably useful. So we might go through just to show what we're talking about. I'm just going to pinch an example here. So if we're talking about posting, so this is Postman, which is a useful tool for connecting in to APIs and things and working with APIs. If we're talking about creating a Fire resource, we sort of need to have a valid Fire set of content. So if I start off with, I'll get rid of some of the noise here. If I have a Fire resource, I can happily, this one's an Australian style ones. I've got some Australian extensions on it. I've got a name, I've got phone numbers, email addresses, all useful patient details, some details, other content there, and a couple of references out to things, organizations that this patient's linked to. So if I actually want to go and create a resource here, I might be able to do that. Now, if one of the useful things to do is there's actually plenty of useful play. There's actually sort of play areas on some of the big server companies. Now, Happy is one of the open source Fire servers. So this is just a publicly hosted Fire server. So if I can actually browse to here as well. So take let's take I'll go to the root. So this is just the root address. So this is actually the hosted public Fire server here. You can see this is the base URL. And yeah, this is their top level view, which is just showing how many records they've got of each resource type in their server at the moment. This is an open one. People play with it. There's some of the calls I was talking about earlier, plus others. And with this, we can then start interacting with this server using the API. So if I wanted to say post a patient to this record, I've got some content here. I'll show you. I'll go through what people usually get wrong. So I go, great, I'm just going to post one. So immediately what's happened is you go, oh, why has this failed? This is a valid patient. I'm posting it to the right place. But there's actually an operation outcome that's in the response here, which is a way that errors can come back. And it's told me what I've done wrong. So it says, oh, when you want to do a create, you have to have, you have an incorrect content type of text plain. So I go, in my headers, I see here that this is not a known MIME type for the content that I'm sending, because this is a Fire server. So they're expecting us to sort of tell them what type of data this is. So we can happily add our Fire-based MIME type. So that's grand. And the other thing that I might want to do as well is indicate. Now, some servers are more accepting than others in terms of how they respond, cleverer than others. But also, I will also say, I'd like my response to be in JSON format as well. So I'm going to post a JSON patient up, and then a response will come back. Now, when you create a resource in Fire, it actually responds back with the content that was created in the system, which is actually quite helpful. If an ID has been added, it'll be included in that response, plus any sort of adjustment that's happened. So if the Fire server doesn't say accept all the elements or something like that, you'll see exactly what is actually stored. So if I actually go post this into Happy, that's succeeded. I've actually got a 201 created response, so it's all been good. It's allocated an ID here, so I've got an ID that the server's allocated for me, and I've got essentially some metadata saying this is the first version, last updated, which the server is maintaining, and then I've actually got the content that I posted in there. So I've got my sort of content all there and available. So having done that, I now know that this ID exists in the system. So if I want to go and have a look at content, so say I want to look at that particular one, I've got my get call here to just read back the thing I've just created. I know that Happy's friendly, but I'll show you. Normally you would set the accept header here. So I want JSON format, so I can happily read that back, and that should be the resource that's there. So I can actually see the resource that I created is in there. If I was, say, a system that wanted to use XML instead of JSON, I can actually say I prefer that my response was XML, and if I go and do the same thing, I get the same resource, but it's coming back in the Fire XML format. So that's helpful if you're one type of system or another. That's probably good for that. And also, as well, as far as searching as well. So say I want to do a search across the system. I did one earlier and actually know there's already an Essler in the system, which has a different ID, but at the moment there's only one of them, and I've just created a new one with the same family name. So if I go and do a search now, I expect there'll be two in my response. Yep. And then so I've got the original one that I had, and I've got the one I just added here. So this is the response. So the way the response has come back is actually in this bundle resource, which gives you essentially a set of things that come back. It lets you have multiple entries in there. Bundles a whole. I might spend a little time doing a session on bundle actually, because there's a whole bunch of little sort of things you can do in terms of how big your bundles are that responded, and how you can navigate through pages in a response and things like that, which is sort of typically if you have a lot of data. But yeah, we've got a simple case here where we've got a couple of resources being returned on a search. So that's it's just showing the sort of search call. We've got essentially parameters on the end. We'll have a look at some of there's essentially every resource has a set of different search terms that are possible, search criteria that can be used, and so that sort of defines the way you can interact with that resource in a standard way in Fire. So that's something that's part of the core specification. What's another good thing to do? Let's do, say, an update. So I've got my new resource. So we do a put, and I want to say, well, I want to kind of keep it the same, but if I want to do an update to it, I'm going to supply this content. I noticed I put the wrong address in. It should be 62, not 621, and my email address has changed. So this is like just something to update. So I've got some differences there. So I'm now going to say, okay, great. I'm going to post this new version. So I've got the same ID here. And I've also included the same ID in my content. This metadata is not really necessary, but you can have it. And then we can post that in. That'll do an update to our system. The response has come back and says, oh, now we've got version 2 of this patient. And we've got essentially the changes will be made. So I've got my updated email and I've got my updated address as well. So it pretty much that's with that you can get by and do a lot of business. Basically, you can do searching, you can do create, update. We can do a delete as well, just for good measure. So,
Brett,
go ahead.
I'd point out for the put, you probably want to do an if match header with the version number in it, so you don't stomp someone else. I always find people don't until they realize why they need to.
There's a whole there's conditional sort of updates as well, which is what Angus is talking about, which is like getting into these are important in the real world where you sort of have conditions on those updates so that you don't like Angus was saying, if you have a sort of shared file server with multiple systems updating and things like that, it's possible you can overwrite somebody's resource, and you start to get this kind of fight in terms of who owns that ID. So these are all things that the file server sort of doesn't manage that. So you need to manage it as and one of the ways to do that is to do conditional updates, and that's a whole. I'll have to talk about that another day, I guess. It's one of those things.
Just a header where you state the version you're updating, and if when it goes to update, it's not at that version, it'll error back rather than stomping over the update someone else did.
Which is kind of like almost it's just almost like a locking thing, isn't it? Because it's just you might have some change. You have a change that you don't know about, so it's letting you detect that, which is helpful. That certainly makes sense, even just like with a single system and say have multiple users trying to update the same resource, something like that. So that's a good tip, Angus.
I guess it would be helpful if you had a system that worked offline and needed to come back online and then sync, and then you want to make sure you don't stomp over changes that have already been made while you've been away.
Or even just a scenario where you have multiple users on a and have a Fire-based client that is updating, say, patient details, and you have multiple admin people updating the same record, and one's updating one thing and one's updating another part. So rather than it won't merge it, so you're actually replacing the whole Fire resource content. So you need to actually know which version you're updating. So you normally this is almost like a locking thing, right? Because it's about it's optimistic kind of locking where you can go, I've loaded this version, I've changed it, I tried to submit it, but the version that is already stored there has changed. So now my update can't happen. So I need to get the latest version and then do an update. So this is all part of if you do database stuff, that's pretty typical also, right? So it's just being able to manage that data well.
Also, it is possible to use patch instead of put. In this case, you will update like some specific field, and the rest will not be updated. It's another approach to address this issue.
Yeah, that's good one. That's getting more sophisticated in terms of things you can do, but it makes a lot of sense. It makes a lot of sense. It makes a lot of sense. In terms of managing the data more easily, because that kind of gets around that problem as well. Anyway, I'll leave that one there, just to where that sort of at least lets you see some basics. Well, I talked through all these things, so like I'm probably just raced through these. So we did a post, we did how to do a read, searching. We did search with sort of get parameters on the URL there. But it is also possible to do like a post-based search using sort of form data content, which is good if you have, say, a web form, and you can do a post back for that to do a search. So that's a quick connection. So rather than having to convert that search into a URL call, you can happily call back using regular form posts from a web page. Updates we talked about. Deletes, we were going to do one. Let's do a delete. Let's just delete the one we created. So we've got an ID. We've got a URL. That's the right ID. Yep. So now that I'm done with this example, I can happily delete it. What have I done? Oh, it's informational, successful. Yeah, so it makes sense. Operation, so outcome was successful. So this is a good example where you get a response from the fire server. It happily deleted. So if I even go back to my search here, I'll go and search and I'll find there's just one again because the one I've created is gone. Okay, so that just sort of shows a sequence. Transactions. I don't know. I'm not going to get into it. I think today I might come back to like transactional stuff. This is kind of important in the sense of being able to post, and like sets of data. I might just grab one example from. Let me grab. Actually, I'll go. Yeah, I'll just get one. So we say do batches, and I'll just get a batch example. Here's a transaction. So basically, a transactional bundle will include multiple resources normally. In this, and part of the main thing is that each of these resources has a requested action on it. So in this case, post which can create this patient. So we've included the resource details. There's a post request here. There's more patients here. This is a whole set of patients, in fact. There's also some updates here. So this is an update here. Here's a conditional update, which is helpful. There's a delete of a patient. So essentially this one's just showing a set of different actions. This is actually not a good transaction example, but these are all going to go in together. So I think it's, so what's it's implementing? Anyway, that's the example. So basically there's a set of requested actions on a set of resources. And because it's a transaction, it has to complete all of these, otherwise there'll be a rollback. And a batch is similar in structure, but it also doesn't require all of the actions to be completed to complete the whole set. So it is possible to do get a mixed response where some things are successful and some things have failed. It's also helpful, like a batch get is a sort of really useful thing to do if you have a whole set of resources that you want to be able to pull together for a purpose. I'm just thinking one of the common things we've talked about in various presentations is about populating questionnaires. Is where we know we have a set of we want to get a whole set of do a whole set of searches for a particular patient. So this is a good example of that, where we're getting the medication statements for a patient, the allergy intelligence for the same patient, and conditions and medication oh, that's for a different patient. But and oh, that's not given. So yeah, so this is basically selecting a set of data to return, and then being able to make a single call and get a response that covers all of the results. So like that's the request, and the typical response would be all of that information in a set. So basically there's a response set, so we essentially get the content, and we've got all of the things that we've requested. It actually doesn't, is that the right one? I think it's the wrong one. I think that's a bug. Anyway, but so the yeah, that's a way to do sets of things together, and they can either be transactional altogether, or just each one can have a separate response on that. I might talk about that another time. there's some nuances, and it's probably a good thing to actually have a play with as well in terms of doing things. I did want to look quickly at capability statement. So that was sort of the describing of how systems work with. So I've just pulled the Happy Fire Server sort of a capability statement. And so this is actually a fire resource that's defined. It's in the specification. I'll just sort of point at a high level set of things, but it's really there's quite a lot of detail here to go through. So the thing will be is actually as a server, they're essentially being able to set things like knowing which resources are supported. So since this is a full fire server, every resource will hear. So if we say, look through all of the so we'll find let me just still tuning. Just trying to find the patient. But anyway, so the for each resource type, there's a definition of what is possible for that type. Let me, I think sorry, it's just updating slowly. That's so big, it's taking forever for me to get through. But yeah, for each resource type, there is so say we've got a patient resource. This fire server, this is basically saying what profile of patient do we support, and this is actually just the standard R4 patient URL. So this is saying it's a standard sort of patient content. Here's a set of other supported profiles. So there's a set of sort of constrained profiles that are defined here. So these are different profiles people have loaded into the Happy server. So for us, we would say, oh, well, we could load the AU core definition and the AU base definitions for patient, and they would become known patient profiles. And there's all the set of interactions you can have with the patient resource. So it's got all the things you'd expect because it's a full fire server. So you can do create, read, update, all the things you expect, and then go through all the different capabilities that are defined in the possible Fire API interactions. So these are sort of describing the things that are possible based on the Fire standard. So this is a really and into as well, like things like the search parameters that are available. So I can search by birth date, deceased date, and a whole bunch of things, the type of that search and so forth. So this is really defining the capability of the system. For a full file server, this reflects the R4 standard pretty much as it's written. So that all the search parameters are available, all of the interactions are available, and you can do all the things you need to do. However, once you start to say, I'm building a facade on the existing system, it's unlikely you could go and try and implement all of the searches, but you'll probably find you don't even have all of the data to be able to do all of these search types. And so some of them don't make sense. And it's also really hard to implement that across a legacy sort of database structure. So you will probably only do a subset of these things. And I think as well, what we're getting to is that things like AU Core will sort of have a set of standard things that we're sort of expecting to exist, which will be a subset of what is possible according to the FHIR specification. So if we start to say we want to create a capability statement, we can actually say, from an AU Core perspective, we will only need you to search by gender, date of birth, name, and that's it, right? And that might be the starting point. So it's something that lets you describe that formally, and this is in the sense of being able to describe what's possible against a particular file server, but it's also a tool to be able to describe the kind of capability a system needs to have to achieve a particular implementation guide sort of use case, and that gives you then something to work against to be able to build a system that implements that capability. So it's a good way for systems to sort of be able to talk to each other and be able to say, you can query, can you achieve this level of capability on a server, and you can actually technically check that the server is asserting it can do certain things. So the server will say, I support patient, I support search by patient by family name, so therefore the connecting system knows that it can do that kind of search for patient. So it's just a way to describe that in a formal way, and often there's actually a formal relation to things like Open API, which is sort of other ways to describe APIs, and certainly there's been lots of work on how those things relate to each other, so it's worth knowing. So I just wanted to point to a couple of the places where capability statements have been put into some of the IGs that we've worked on. So AU Core is sort of one that's everyone's kind of looking at now. For AU Core, there's been kind of this split. This is all work in progress for AU Core, so these are all sort of just reflecting a sort of draft capability. There is a split of server and client capability, which is kind of needs some explaining, but I'll kind of probably just look at the server capability at the moment and take it from that, and we can talk about the differences later. But basically this is being able to sort of describe the capabilities of systems. So really it goes through all of the resource types we sort of have defined, the profiles that we have defined. So these are essentially, so this kind of gives you a scope of these are the resources that AU Core talks about in this implementation guide. So we kind of don't say anything about any of the other resource types at all. There's a set of profiles, which are sort of the profiles that we assert for AU Core. So these have their own rules in terms of elements that must be supported and mandatory elements and things like that. So there's some sort of rules there, and then as well there's some concept of saying here are a set of searches, some of the search parameters that we have defined as being needed for this resource type. So these are really, so I'll find patient because we always look at patient. So in patient, we've got our defined scope and content here. So we say, yeah, we do patient, we do an AU core patient. There's a set of search parameters we support. This is very much a subset of what's possible in the core specific, like the Fire core specification. But you'll also notice there's actually an additional one, which is actually a search on an extension included. So we've said something about including search by an actual extension that we have defined in our core patient record because we think it's an important search capability to have. So these are sort of, it's an ability. So basically, what we're talking about is defining a set of so as well as the data, which we've kind of got our patient resource data, sort of being worked on in terms of things we need to support and the content and structure of that. We also then go down into the searching sort of criteria as well, and we are trying to state some conformance and capability levels around those things. So we've kind of said we need to be able to search by these things. We should be able to search by all these types of thing, so mainly name and birth date and things like that. There's some combinations there because it's like Fire says we should be able to search for all these things together, so like doing an and but certainly like in things like some of the international standards, there are sets of things that we are explicitly listed. So this is getting down to explicitly the searches that you should be able to achieve with this system. Now, if you have a full-blown Fire server, you don't even have to think about this because your server can do all of this. So digital status is probably the only thing you need to think about because that's working on an extension. But an out-of-the-box Fire server can do these things. So if you're sort of running an out-of-the-box Fire server, this will not be frightening at all. In fact, you just say whatever you want, that's fine. As long as it's Fire standard, I'm good. But if you have to implement these searches, this would be something that you need to go back and implement a search against your own data and be able to supply a result for. So it's a lot more complicated if you are implementing your own search implementation, and you probably need to have this for anybody building facades on existing data structures to be able to achieve sort of a level that you can then rely on going forward. So that I just want to kind of point at that. So that's AU core defining that capability. But provider directory also has a similar thing. So this is the provider directory. So looking at practitioner, we did a very similar thing for a provider directory. So that's broken. I'll have to go and fix that. I might have to. I think there's a publishing problem. I'm gonna have to go through this way. But with the definitions we had for provider directory content, same thing. We've got some restrictions here, and we've defined a set of search capability that was agreed. So this was basically built around a use case of provider directory usage. So there's a whole set of things there that are specific, even specific identifier types for searching and things like that. So when it comes down to it, as part of the Fire implementation guide work, we will be discussing the interactions and down to a level of down to some detail in terms of what's possible and not possible, because all the things that are decided need to be included are things that people need to implement. So it's definitely something about saying what's actually needed, what's the useful searches, and how far are we going to go initially are probably the big questions. I've blown through an hour, but I covered all the things I really kind of wanted to cover. So were there any questions or comments? There's a lot more to each of these things, but it's kind of just trying to get a briefing that basically there are these kinds of interactions. We will be talking about them as part of our discussions in terms of the implementation guide. So just to give people a bit of a background on what we're talking about when we say search parameters and interactions and all the things we're talking about, so people can have a bit of a handle on that discussion. Any comments? I hear none.
That was a good walkthrough, Brett. Thank you.
Yeah, it's one of those things, because it's like you go, oh, this is a can of worms, so it's very hard to stay at a level. It's more
important to make sure, because there's a lot of assumptions about what people know and don't know, and I think it's good to if we start at the base and start to work up. I think that just makes sure everybody's on the same page. So yeah, well done.
I'm trying to sort of link it to some of the discussions we'll have in the technical design groups and so forth, because it kind of, at least then, I think hopefully people, once people are implementing this, will all make a whole lot more sense immediately. Cool. So it's no worries, Michael. Thanks. So it's kind of so I think it's something that, once people are implementing, they'll get into more detail, and there'll be questions that come out of that. So I think it's more, but I think to have the high level discussion in the committee work, it's kind of good to know at least some of the basics. There's a whole bunch of interactions there I glossed over quite a lot with, because I don't think we're going to necessarily talk about those very much especially in the AU core group. E-requesting might be a whole other story of level of detail, I think, in terms of some things. But still, I think it's useful to have these are really the basics. You can actually do a lot with just the basics. I think it's at least have some of the language there that people can then can delve into when we have the discussion. That's hopefully helped a bit. All right. Let's
Thanks
call for
very much.
any last questions. I will put this up on the HL7 site. I might just point at that just for good measure. So on our this is the HL7 space, which is not the fire work group or the other space. So this is essentially the affiliate space. There is a recordings area. So we've actually got the previous session plus the IPS discussion we had recently. This will also go up as another recording. And yeah, if people want to share this with people, that's all good. And we can. I'll just keep this page up to date with anything that's sort of this style of informative material, and hopefully then people can catch up if they've missed it as well.
Hey, bro, I have a random question. This is David Wales, from Sydney Primary Health Network. So I don't know if this is quite the right forum for the question, but just something that came into my mind. As a primary health network, we are mainly interested in de-identified data. We like unit record data, but we don't want the identifiers in there. And I'm just trying to think in this kind of fire future, just trying to imagine what that looks like from our end. Like it's great to have this standard that everyone's talking the same language. I'm just imagining, like, would we run some kind of fire server on our end that would then talk to the providers we're interested in and get the data we want, or
that's the idea? That's a good question. There's a good question, because it's like I think there's kind of if we're talking like AU core, we're saying we kind of expect systems to make available this kind of interface, this kind of data. That's helpful in the sense that what you can get and how to get it. But to actually say that's going to be available at any point, there's a whole set of sort of security and scope of access sort of things, questions that come into how you would get access to that. So some like I you know, some people will set up maybe a security, depending on the system and the implementer. You could say this just runs inside inside a clinical scope, right? So it just runs at a service, and it's not accessible outside the service. That's one option. But it means like though you can still run tools inside that zone that can rely on that and collect data and do things and then send it out somewhere or do whatever business you need to do. And sort of there's other options where yes, you do have this as a cloud endpoint that has some security model to access it, and now you can set up relationships between parties and do some collecting data and doing business. But that's I kind of think like implementation. That's more of an architectural question about how things are going to go together, and less about the data and the Fire API directly. So I kind of see a world where I expect a lot of the systems will have cloud-based endpoints that are accessible, and there'll be some connection process where you do what you need to do to get authentication and authorization to access things. That will be a part of essentially their security and models like that. So I think a lot of we haven't said much about that in terms of how that would actually be, and a lot of it I think will be maybe system dependent or even just policy dependent questions. So I think we'll get there, as saying we want to have more standard ways of knowing we can connect the systems in particular ways, but that's kind of not on the radar at this level. But having said that, like having an interface that what it's going to do and how it's going to behave is super important to actually make sense of the data once you can get access to it. Things like de-identified data. I think one thing to think about is like standard approaches to de-identification. How do we, what kind of features does de-identification of data have, in terms of like AU Core describes identified data sort of patterns, but it's the ability to take that and turn it into something that's considered best practice. So in terms of quality, the identified data is probably it's helpful to have a fire spec to start with, because you can start to define standard behavior in terms of what's acceptable from that known identified content. I think there's a lot of things to think about in that space in terms of de-identification and how to manage that, because there's kind of different levels. I could say, hey, it's easy to strip identifiers and names from a patient, but there's it gets a whole lot more complicated when I say, oh, but your reports have patient details in them and also population-based sort of things where, it's rare diseases. You have a rare disease, there's only 3 of these people in Australia, I know who you are. Things like that. So it's there's a whole bunch of actual regular de-identification concerns and privacy sort of concern stuff that is kind of, there's been lots of work done on that, but I think as well we have some sort of practical questions to say, how do we do things like population health in GP space and things like that, which are kind of typical things people already do now in some fashion. So but I think having a standard API is a useful tool to be able to say, assume there's a standard API, now we can define what happens next downstream.
Yeah, I'm definitely excited for a standard API. Another question, sorry if they're running out of time.
I'll just say, like, if other folks want to jump off, feel free. Also, if you have questions, hang around, or are you interested? Yeah, cool.
So you showed us the JSON and the XML responses. Is there kind of a Fire relational model? So I'm thinking like a SQL approach, because I'm thinking from a PHN perspective, we're interested in the analytics side of things. We're not so much making apps to to show patient records or update patient records. We just want to do kind of population analytics.
Yeah.
Sorry.
Yeah, like there's a world of things happening around fire in that kind of space, some of which I know more or less than others. So the other what was I doing? I was going here. So there's certainly like just thinking of best places. The like the fire specification itself has some support for these sort of population based records. So this is kind of, there's different levels, because there's kind of like this reporting concept where you can say there's population reports basically, which are kind of like the things you'd expect with like metrics and measures, right, in terms of that kind of thing. So that's kind of like a first class fire concept. So there's like this sort of report thing, but then there's also sort of the definitional stuff to say, how do you create a metric to be used? And one of the tools to do that is this thing called CQL, which is clinical quality language. So it's actually a way to describe how to calculate a metric. So that at the moment kind of sits outside of fire. So these are like expressions that can be used to calculate a value in a so that you could basically create population stats, from that sort of definition. So that's more definitional stuff. I think that's kind of a developing area as well. But like the fire spec, like this is actually in the fire spec. I'm not sharing that will help. That will help if I do that.
Someone needs to write the Wikipedia page for it as well.
Yeah, it's like one of those areas. It's definitely a developing sort of area. So this, like in the fire spec itself, there's kind of like some stuff about quality reporting, they call it, but it's really like it does things like population metrics and things you expect in sort of population reports. That's kind of more where you have well-known metrics that you want to sort of calculate and produce reports. And there's a definitional way to describe that. So this is pretty it's pretty sophisticated. You can build up expressions to say, how do I use the fire data to calculate a metric, and then actually have a report generated as fire that represents that. So that's quite a interesting area. So
we might be trying to count how many people in southwestern Sydney have diabetes, how many have diabetes and heart disease.
Yeah, from a definitional sense, this is the kind of set of tools that would do it in a very formal way. So you could actually say, this is how we measure diabetes populations, which has to do stuff like include terminology and how do you define a diabetic, as well. So it's so there's some sort of tools to help you express that and actually represent the results in a standard way, but actually the definition of what it is and how to get a system to do that's another thing. But it's actually there's a whole framework, and this is definitely getting used, this kind of approach around using fire data to generate sort of metric based reports and things like that, which have definitions of, it's exactly what you're talking about. It's just like population stats and all the normal things you do. You can do this sort of breakdown, which basically do disease and age and gender and all the things you'd kind of break down normally to just do like population level stuff. What medications they're on and for treatments they get and all of that kind of stuff. But I think too, like that's more thinking of it as I've got a set of data now, I'm going to produce a result. But if you want to think about it more as more as a data set to use in doing analytics, sort of ad hoc analytics, that's probably a different question, because you kind of need to get it into a form where you can start to do just investigations into things. So there's certainly stuff like mapping, like there's been a whole world of mapping fire data to OMOP, which is like a standardized tabular sort of approaches to things.
Right, okay.
Brett, is Pathling something in this space?
Yeah, Pathling's, that's a good one. Pathling's a CSIRO. Pathling's, I missed an L. There it is. Yeah, because Pathling's like really much this is a CSIRO project. So it lets you sort of, essentially it's a lot about flattening out the fire data into tabular representations, which is kind of really much easier to deal with for the analytics side. So, and it's also like being a CSIRO tool, it's David, we're actually just finishing. I'll let him know. So it's like, because being a CSIRO, it's got like a lot of the onto server, because a lot of it's about classification, right, and being able to classify things into tabular. So I want to have a column that represents diabetic, yes or no. I have to define what that means, and depending on my terminology concerns, that might be a complicated question. But Pathling kind of is a set of tools that is meant to help do those things. So flatten it out. It's very much, and you start to like there's useful things like even stuff that I've seen, taking fire data directly and doing connections into sort of statistical tools. So being able to like R programming and doing statistical tool connections and being able to directly do, which essentially lets you jump into sort of stats packages and do more of that hardcore analytics work. There's like a project, I think, R on Fire, which is like linking that. The stuff that I've played with the most successful is just doing flattening and just going, I have a definition, I flatten it into tables, and then you can definitely just load all that stuff into like a stats package, and you can do all of the stats work directly. Just from raw data. So that's kind of like, I take my patient resource and turn it into a flat patient table, which selects, basically it's selecting the things you care about and defining what you mean. If I want to do, you rapidly run into terminology and questions about how you define diabetic, and which is getting into that's more of a source data question some of the times too, about how good the source data is. And
I don't know if you mentioned it. Isn't there SQL on Fire? You might have sent that.
There's SQL on Fire, which is like, again, that's another one.
There's some implementations of that, isn't there? It's like an emerging standard on top of Fire.
I don't even know.
AidBox does it, don't they?
Yeah. You're good at this stuff, Angus.
I might know it, doesn't mean I'm good at it.
No.
I've heard of it.
Because it's interesting because there's all these little communities existing that everyone kind of needs the same.
See,
same things.
See John Grimes there. He's the guy who does the Pathling.
Oh, yeah.
He's the Pathling guy.
Yeah. John's good to talk to.
Yeah, I was thinking John's probably a good person for you to speak to.
Yeah, and because he's in charge of the Pathling tools, and
he's probably better than Brett and I at directing you as to where you should be going. Like he's
that's
deep in that space.
It's kind of a question that my team has been having. We're excited about Fire and we're keen to be involved, but I guess we're kind of that next level. Like the first stage is you've got to have the systems that talk Fire, and the second stage is we want to now use it for analytics. And so we're trying to puzzle that space out and figure out what we need to do to be involved in that.
John did a great demo of where he got Queensland health data, which was in HL7 version 2, and then converted it to Fire, and then used Pathling and did all the statistical stuff on it. It was quite interesting.
Right.
Yeah. A lot of it's about the flattening, because you're still even with Pathling, you have to decide what columns you want to define, and I think there's a whole world there where maybe even standardizing, which is kind of like there's this OMOP stuff to Fire to OMOP, which is kind of there's nothing like off the shelf.
I guess Fire wasn't designed from the ground up for this purpose, and then what's happened is it's created a standardized way to express health data, and then people are building tool chains on top of it to do it. Because
the whole point, like anyone in OMOP will tell you, the hard bit is actually getting the data out of the system into the common data model, right? And Fire is the common data model, right? So if you can actually say systems do Fire, it actually streamlines a whole bunch of stuff that people are taking years. I went to a talk from Monash during the week, and there was someone who had spent like 2 or 3 years doing hospital data mappings into OMOP, and it's like, and then that was normal. And that was like, that's one system in one hospital, right? So so the Fire stuff is potentially a good way to sort of make that more of formally well-known conversion. And so that really it also means the concepts are kind of defined a lot more regularly.
It's a difficult time now too, because if you really want to do something now, you're probably looking at HL7 version 2, and then there's people trying to convert that to Fire, which is probably a better output. And so we're in a transition sort of phase.
There's definitely things like if you have Fire data available, like you can definitely take flat table views out of that. That's actually not that difficult in the sense like but you are taking essentially a subset of what's there, and you're doing classification anyway along the way, because like you'll just say anything in this terminological subset means they have diabetes, right? So you're not going to have 50 different codes. You're going to have they've got diabetes or not, right? But that's a decision. That's almost like a classification problem. So I think there's that, in the absence of having standard classifications, saying like there's no, like, I don't know if anyone's publishing how you take this Fire data and turn it into a standard metric. And that's kind of what some of the tools will let you do that, like CQL and Pathing does it along the way, but there's a lot more. I think Pathing's more of a tool than defining how it should be done. So it's I think still there's a lot of actual health data questions about how do you actually know what it means with the data that you have. But it does let's say, well, you could possibly have some tools. I think the good thing is saying, if you start with Fire and saying Fire represents the actual health record in detail, that's actually helpful, because then you can start to say, how can I create more classification or population-based views on that in a standard way. And then, because at the moment you kind of have a whole bunch of custom models being mapped into a population set of stats, right? So
exactly.
At least that would get started.
That I know of. That do three completely different models on top of all of the different practice software. And they try to present a unified model of it, but then there's 3 separate unified models.
Well, Welcome to
And then
healthcare.
when you're looking at like models, there'll be a little asterisk that says, "Oh, this field's not available in this medical software, so we've given it to you, but you only get it for one software."
One software, yeah. And I think it all boils down to the systems, because the thing is, like, what concepts are actually described in the originating system anyway? And do they mean the same thing? Right, they're good questions. So there are definitely things that are usable and people do, but I think part of the journey.
I often feel our data standards like FHIR, even V2, are more advanced than the clinical workflow standards. So asking for clinical organizations to standardize what they collect and how they collect it is probably further behind than the actual data structures to collect it.
Yeah.
You can hope that having the data structure will encourage them to use the data structure.
Yeah, we tried that with CDA. It's been we've had the data structures for a long time. It's trying to get them to. I often feel the standards are missing from the clinical workflow.
Yeah, and there is a level. Yeah, I think, like, with this whole FHIR Spark thing, like, part of it is this whole clinical design group thing as well, which is more aiming at the clinical structures and that kind of more underlying set of well-known health information. But it's kind of taking a step. The thing is, though, it's taking a step backwards to go forwards, because it's really, like, it's not going to be as sophisticated as what you can get now, right? Because we're kind of saying we're starting with a subset of things, try and build standard clinical data models. So part of this whole Spark thing is to do that. There's going to be clinical models built. So there's working on actually formalizing clinical data sets, which AHW is going to look at, and others as well, and more from a clinical perspective and a reporting perspective as well. But then that has to be linked and mapped to the technical FHIR work as well, in terms of how those things are represented in the FHIR data and how systems would do it.
But it has to be adopted by a clinical community, not just by a group of 8 clinicians.
And the thing is too, that's actually, I think that's where the hard questions are, where you say, do these concepts exist faithfully in your system at all? And if you have something like that, but it's not quite the same thing, that affects the ability to use it downstream, right? So these are all good questions. I think the clinical data stuff is actually really interesting, because I think we should be thinking about how, because that's effectively saying this is the correct approach to collecting this kind of data, in terms of what the scope is and the content, and which also means, what should my form look like on a system, what terminology should I use, and a whole bunch of things that would affect how systems are actually built. So plus you could say, well, decision support should be built on those clinical concepts, and then we need to actually create an implementation on top of that, right? So, because you should be able to define all reporting decision support against those concepts. And then the FHIR representation is really just saying, this is how I get it out of the system, so I can do those things. So anyway,
you part of
that's a whole world. That's a week's work, that one. That's a week's presentation.
Is that the CRISP project, David, that you're involved with, or not?
Me?
Yeah.
I don't know about the CRISP project.
Oh, it won't be then.
Don't know that one. Yeah.
No, I'm not exactly involved in any particular projects. I'm kind of just getting looped into the FHIR world, I guess.
Okay.
I'm just a data engineer at Southwest Sydney Primary Health Network. So
okay. I'm just going to say, for those listening to the recording, I'm going to stop the recording now.